In this video, I want to take a look at the length of a vector in R3 and how we calculate it from the components. So I have a vector here, ABC. I happen to plot it as 1, 2, 3, but the actual dimensions themselves are irrelevant. Let's just call them ABC. So A is the length of the blue line segment here, B is the length of the red one, and C is this green one that goes perpendicular to the xy plane. So the x component, the y component, and the z component there. Now, to find the length of this, I want to use the Pythagorean theorem with a right triangle between this purple and the green. Those two are, purple is in the xy plane, the green is perpendicular to the xy plane, so that's a right angle right there. Which means I could use the Pythagorean theorem. I know how long this is. I don't know how long that is, at least not right off the bat. So the first thing I'm going to do is figure out how long the purple thing is, because I have another right triangle using the blue and the red edge to be the purple, the blue, the red, and the purple to be the right triangle. In fact, I can show you, I think I can show you that that is a right triangle by just looking straight down on it, and I see that it is indeed a right triangle. Okay, so this is looking straight down the z-axis, and you can see the right angle right there. So I'm going to use the Pythagorean theorem on that triangle to figure out how long the purple side is. So in particular, the purple side is, well, a squared plus b squared equals c squared. So call that purple side, well, not c, because I've already used c, but this side squared plus that side squared is the diagonal squared. And so the diagonal is the square root of a squared plus b squared. So now, looking at the triangle with purple, green, and the vector we want, I have that the bottom side there is the square root of a squared plus b squared, and the vertical side is c, and I want to know that hypotenuse there. Well, how do I use the Pythagorean theorem? I square both of these two things. So when I square the a squared plus b squared, well, sorry, when I square the square root of a squared plus b squared, those are the square and the square root are going to cancel out, plus c squared. But that's, if I don't put the square root there, that's the hypotenuse squared. I actually want the length of it. So I want the hypotenuse. I want the length of the hypotenuse, so I have to take the square root of the whole thing. And I end up with the square root of a squared plus b squared plus c squared. I use the Pythagorean theorem twice. Once on the triangle down in the xy plane, and then once in that vertical triangle. Let's see if I can, oops. There we go. I don't know why it wasn't letting me move, but that vertical triangle you can see has a right angle right there. Anyway, there you go. There is the length of a vector in R3, the square root of a squared plus b squared plus c squared.